Hi and welcome. So this video is an example where we can apply the universal law of gravitation. Assuming that we have two identical satellites that were launched to orbit around two unknown planets to discover or to study the condition of those planets. We have planet X and planet Y, and we have identical satellites. Okay, two identical satellites that will go around in orbit around the planet, around those two planets. Let's say that the distance between the satellite and planets are the same. They are identical, r. So those distances are identical. However, planet X, okay, planet X would have a mass of X, and this one is mass of Y, and we all know that mass of X is twice, okay, is 2 times the mass of Y. Okay, so 2 times the mass of Y. So that's the condition. Well, we can just assume, since these are identical, you cannot really assume, but it's an identical satellite, so therefore the masses will be the same. So, question is, how strong is the force or the gravitational force between the satellite and planet X compared to the force of gravity of planet Y, the force of gravity between planet Y and the identical satellite. So, first thing is to write the equation, which is Fg equals G, mass of the bigger object multiplied by the smaller object divided by r squared. The distances are identical, so therefore they would be the same. The only thing that would be different is the mass of the planets. However, the condition is already given. Mx is equivalent to twice m of y. Now, if they would ask you a follow-up question, which do you think would experience a stronger force of gravity? Now we can answer that question that Fg on planet X blank Fg planet Y. So which one would experience a stronger gravitational attraction? Okay. So going back to the previous video, we all know that the stronger the mass or the bigger the mass, it will create a stronger force of gravity. Since the condition is bigger mass or greater mass for planet X, so therefore it will be way stronger compared to planet Y. So Fg of X is stronger than Fg of Y. How do we prove it? Then let's use this equation. So Fg of X, just use a different color pen. So let's try to solve for Fg of X is equivalent to G multiplied by m of X, m over r squared. While for planet Y, we have Fg of Y is equivalent to G m of Y times m over the square of our distance between the planet and the satellite. Now we all know the relationship between mx and my, so we can actually replace mx in terms of the mass of y. Then we can change it to Fg of X, G, instead of using mx, now that will be 2 m of y, m over r squared, while the force of gravity between planet Y and the satellite will remain the same. So simplifying it further, Fg of X is equivalent to 2 times G. So let's pull out that number 2, and that will give us G m of Y times m over r squared. But we all know that G m of y m over r squared is the same as Fg of y. So this proves that Fg of x is simply equivalent to twice whatever the value of your Fg of y. So yes, it's bigger, it's stronger, it's greater, but by how much? Since the mass is twice, therefore it is also as twice as stronger compared to the force of gravity between the satellite and planet Y. So here's our first example.